Here you see that you have a variable in the numerator, variable in the denominator, and very importantly here, you notice that you have two terms in the denominator. So when you have two terms in the denominator, usually there's no way out of this. You're going to have to go through the quotient rule. So the quotient rule, remember, you have a top function, which in this case would be cosine x, and you have a bottom function, which would be the 7 plus 2 sine x. And then you take their respective derivatives. So remember, dc negative. If you differentiate a c function, you're going to get a negative. So this is going to be negative sine x. And then the bottom function, the 7, is a standalone constant. And then the 2 sine goes to cosine x. All right, so the quotient rule formally says that it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So in terms of our little setup here, you're going to start with the b is for beginning. You're going to do your crisscross and subtract those two and then put it over the bottom squared. Now, when we plug into the quotient rule, that is our step of taking the derivative. So what will happen is we'll no longer have y. This is now y prime. So when we start to plug into the quotient rule, that is our differentiation process. Now you'll notice that the bottom function has two terms, so you have to put parentheses around those two terms. And then the top function's derivative has a negative sign. So we want to be very clear that this is being multiplied, so we'll have negative sine x in parentheses. Minus, and then we take this diagonal. So it's going to be cosine x times 2 cosine x all over the bottom squared. So the bottom squared here is 7 plus 2 sine x, quantity squared. All right, so now comes the fun part of trying to simplify this. So for the quotient rule, you focus in on the numerator only, and you either are going to remove parentheses or you're going to factor out a GCF. Now in this particular situation, if you look before and after the minus sign, that creates your two boxes here. So this is one box, this is the other box, and there isn't a GCF there for you to factor out. So that means that we have to focus on removing our parentheses. So I will distribute the negative sine x to both of these terms, and that will give us negative 7 sine x minus 2 sine squared x. And then over here, I'm going to have a minus 2 cosine squared x all over 7 plus 2 sine x quantity squared. Now, this question is really cool because it actually introduces one of our trig identities. So you might remember the Pythagorean identity that we had in trig class. We had sine squared x plus cosine squared x is equal to 1. So what I could do is I could multiply both sides here by negative 2, and that would give us a true identity, negative 2 sine squared minus 2 cosine squared x is equal to negative 2. So all of this, and I wouldn't necessarily expect you to notice this, but it is important. So all of that is going to actually become just negative 2. So our new rule here, or new simplification I should say, is going to be that we have negative 7 sine x minus 2 all over 7 plus 2 sine x quantity squared. And at that point, you would just have to kind of stop the boat because there isn't any other simplification to do. So if you had stopped up here, that would be fine for the test and everything. But I do want to just mention, like when you see those squares, sine squared and cosine squared, kind of start thinking about the Pythagorean identity because there might be some sort of Pythagorean identity in there.